Suppose we wanted to write an algorithm and a program which calculates pay. So we're asked to write an algorithm and a program which prompts the user for the number of hours worked and hourly pay rate. The program should multiply hours and pay rate and output total pay in dollars and cents to the screen. So for now, let's just think about the algorithm part. And over the course of today's class, we're going to learn all the skills we need in order to actually program and implement this program. And when you're first starting to write an algorithm, you might think, well, oh my goodness, where do I start? One of the best tricks I recommend to students is to work backwards. Start with what the program needs to produce at the very end. Then you can do a bit of reverse engineering. Work backwards to figure out what other steps need to happen in order to complete that task. So let's go ahead and give this a try with this algorithm. And if you'd like, you can also pause the video and try writing the algorithm yourself. And you can compare your result to mine. You'll find there's really no wrong way to write an algorithm. There's many possible ways to do it. The important thing is you want to be clear and detailed. It's as if you're teaching a computer how to do something for the first time. You want to be careful what you assume. So remember, a computer will think a little differently than we do. So let's go ahead and give this algorithm a try. And I'm going to try using that strategy of working backwards. Okay, well, we know what our end result must be, right? We know at the very end of our program, we need to output the total pay to the screen. So I'm going to write that at the bottom. And we want that in dollars and cents. Okay, so that's good. We want to output to the screen. Well, now what do we need to do in order to output our total pay? Yeah, we need to calculate it, right? Let's calculate our total pay. And we may even need to store that total pay in some variable in order to output it. But how do we calculate total pay? Well, we do that by multiplying the number of hours times the pay rate. Oh, well, wait a minute. Now, where do we get number of hours and pay rate? Well, often in programming, just like in math class, we may use some variables. So I'm going to decide to create some variables named total pay, number of hours. Let's just call it hours worked, and pay rate. So we'll use those variables to hold the values from the user. Okay, well, that's giving us some more hint about what we need to do. In order to actually determine total pay, we need to find out what hours worked and pay rate are. So in order to do that, we need to ask the user to output a message asking our user for, in this case, let's say pay rate. And then we need to store the user's pay rate in the pay rate variable. And similarly, we got to do the same thing for hours worked. So we got to ask our user, for the number of hours that they worked. And then we store the user's hours worked in the hours worked variable. Well, wait a minute, where do those variables come from? Turns out in C++, we actually need to tell the computer that these variables exist. We have to declare these variables. We'll cover more how to do that a bit later, but an important step would be to declare variables to store total pay, hours worked, and the pay rate. So let's just declare those variables. Total pay, hours worked, pay rate, and these variables need to be able to store decimal numbers. So we're almost done. Notice we have almost everything we need. The last thing we'll need to do is make sure that our C++ program headers and to make sure our program includes headers to enable inputs and outputs. And if needed, we can format decimal numbers. So there you have it. This is one example of an algorithm that you could use for writing this pay calculation. And this might have seemed like a lot of extra work, and this seems so simple, right? Like a lot of students might have been able to just sit down and write this program from start to finish. But imagine if you were trying to do something a lot more difficult than this. Many of the assignments in this class and programs you'll write in the real world are going to be significantly more complex. So mapping out this plan is so important in order to develop a program successfully. And now that we have this algorithm, you'll see it's actually pretty straightforward to figure out what our program needs to do. We basically just need to learn how to declare variables, how to do inputs and outputs, how to perform a calculation, and how to output stuff to the screen. Let's now talk about how we actually learn to do each of these things in C++. So once again, here's another possible solution. So there's really no right or wrong answer. Every student will write algorithms differently. But you want to make sure you are as clear and detailed as possible. Another actual strategy that is helpful for beginning programmers is to actually write the algorithm as comments in your program. So we'll demonstrate this a little later, but you can see that if you actually break down your algorithm into comments, then it can help guide you through the programming process. And it can make it a little bit easier to implement that program and follow what's happening. So here's an example of using cout in that pay calculation program. So notice if we want to ask our user how many hours have they worked or what is their pay rate, or if we want to output the total pay to the screen, notice we can actually use cout statements here. So if I were to write our cout statements as shown in our previous pay calculation, you'll see that all the lines are outputted on the same line. Right? Notice we have how many hours have you worked, and then notice, so our first cout is here. Then the second one, what is your pay rate? That's immediately outputted on the next, just immediately to the next part of the text on the same line. And finally, the total pay outputs are all on the same line. That's not very readable. And so you'll see, instead of outputting that way, we can add this \n, or we can use ENDL. We can use these to make the output appear on a new line. So notice in this case, the \n, that will create a new line after the output. So we'll output how many hours have you worked? And then notice the new line. And then the next, what is your pay rate, appears on the next line. And then we output what is our pay rate. We have another new line, so the next output starts below it to give us the total pay. Let's go ahead and take a moment to demonstrate this in CLine. All right, so let's just briefly demonstrate this example for everyone's reference. So you can see here, we have our code as shown in the slide. We have our IOStream header using namespace standard, and notice we have these cout statements. Also notice each cout statement has a semicolon, and if I forget that semicolon, I get some messages from CLion asking me for that semicolon. So let's make sure all our semicolons are present. And now we can go ahead and run. So I'm going to just run this example. And notice in my output, I see the output is all on the same line. But if I instead put in what's called those escape sequences, like the /n, this will create a new line. So if I put a new line right after how many hours have I worked, but inside the quotes, notice now, before my next output, this next line will appear on a new line of text. So I can similarly notice the /n must appear inside the quotes in order to work. Oops, let's do /n, not /m. So if I put both of those escape sequences in there, notice now each line appears on its own separate line. An alternative way that others often use is, instead of using the /n, you can also do end line like this. It does the same effect. It basically just ends this line. So you see, if we use end line, that will also produce the same output. Notice if you use the end line, then you just have to make sure that that is not included in the quotes, but you do have to have another operator here between your quotes and the end line. All right, so let's go ahead and finish this program. So I'm going to declare some variables. And you might be wondering, well, why am I using double here? Well, we don't know what input the user is going to give us. It could be a decimal, maybe they make $10.50 per hour. Maybe it's a whole number, like $20 an hour. We don't know for sure, so we want to be able to take either decimal or whole number inputs. So we're going to go ahead and use double as our variable type. So here we've declared our variables hours worked, total pay, and pay rate. Next, we outputted our message to the screen asking our user for the number of hours worked. So after we ask them, we want to store that value into hours worked. And notice CLion is kind of popping up the variable name. It's trying to help me as I type in that variable. Next one, output message asking for pay rate. So same deal, right? We ask our user, okay, what's the pay? And then notice we can take in cin pay rate. And I need to include a semicolon after. And then finally, notice I can calculate total pay. Total pay is just going to be hours worked times pay rate. And notice here, for my output, I can just do that, and that will output my total pay to the screen and just leave a new line afterward. And notice now we are ready to go ahead and run this program. So let's go ahead and run it. So how many hours have I worked? Notice the program has paused. It's waiting for me to give an answer. So here I can say 40 hours, and notice if I put spaces, it just will end up ignoring those spaces. What's my pay rate? Say I made $15 an hour. And notice now I got my pay is $600. Another thing to notice is that here the cin will read the 40 and then pause, and then it will read whatever comes next in the next statement. So here it read, how many hours have I worked? 40. That stopped reading. And then the next cin statement went ahead and took the pay rate of $20 an hour to get 800. So you want to be a little careful with cin because if your user enters something with spaces, only the first thing before the spaces will be saved in that variable. Okay, so I've returned to my original example. And so here I'm going to include iomanip. Remember, we need this to control the decimal places. And then what we can do is we can output fixed to show the decimal, and then we say set precision with 2, and that will ensure our total pay is showing only the correct digits. Let's try with and without so you see the difference. If we do not have the set precision there, notice if I work a lot of hours and I get paid a lot of money, I get scientific notation and a large number, right? And I want to see dollars and cents. I don't want to see $9.99999 times 10 to the 10th. So to fix that, that's where fixed comes in to always show the decimal. And then if I do the set precision 2, Notice if I rerun the program in the exact same way. Notice now I get my dollars and cents, even if the number is very large. So this is just another way that you can use some of the tools we've learned to nicely format your programs. So I hope you found these examples helpful, and I highly recommend that you go back, try coding this up for yourself, and playing around with it. One of the best ways to get comfortable at programming is to sit down and write programs like this on your own. Verify that you're able to get the same result as we did.